So let's talk about the chain rule in differentiation. So the chain rule tells us how to differentiate, to take the derivative of a function of function. Let's look at this one, it's quite good. So if we have a function f of a function g of x, when we take the derivative d to dx, which g is defined on, so what we should do is take the derivative of the outer function with the inner function stay inside and then multiply by the derivative of the inner function, namely derivative of f uh, inside it the function gx multiplied by the derivative of gx. For example, if we're taking the function something to the square of n and we take its derivative in respect to x. So we need to take the outer function derivative, which is uh, n times the function is to the power of n minus 1, and this is multiplied by the derivative of f of x. So we can look at it like this. This is a very good one. So when we are taking the derivative of a function in respect to x, so we're taking the derivative of the function inside the function itself and multiplying by the inner function derivative. Or you can look at it if y is a function of t and we are taking and x is a function of t also. No, that's not good. Let's look at this is a good example. So if you want to take derivative of this function ln of x squared minus 1, so we have two functions in it in this formula. We have the ln function of something and the function x squared minus 1. So as the chain will tell us, what we should do is to take the derivative of the outer function with the function inside stay the same, multiply by the inner function derivative. So ln of something is 1 over the something itself. So ln of x squared minus 1 is 1 over x squared minus 1 times the derivative of what's inside, the derivative of x squared minus 1. Multiply the derivative of x squared minus 1. So this is 2 times x. So we get 1 over x squared minus 1 times 2 times x. Okay? So here we apply the chain rule to solve this problem. Also, we can look at it at if y is a function of u and if u is a function of x. I want to show you something like this. It will be good if you find it. Okay, that's look good. Mm, mm, okay, that's good. So if I define it like this, if I have a function y equals, let's do it a little bit bigger here. If y equals 3x plus 3 to the time to the power of 3, and t I make it a function of x, 3x plus 3, so I can define y as t to the power 3, right? This to the power 3. This is how y defined. Now, if I want to take the derivative of y with respect to x, but y is defined with t, what I can do with the chain rule is take the derivative of y with respect to t and take the derivative of t with respect to x. This is the same as taking the derivative of y with respect to x. Do you understand what I do? I represent y as a function of t, but I'm taking the derivative of y with respect to x. But y is defined with respect to t. So I take y with respect to t and t with respect to x in terms of derivative. This is the chain rule. And this rule sometimes we see it this definition of using these terms, so it is important to understand how it looks. So t, the derivative of t with respect to x is 3, the derivative of y with respect to t is 3t squared. So what I can insert here is this 3t squared times the derivative of t with respect to x, it's 3. So it's 9 t squared, but t is 3x plus 3. So I can insert instead of t 3x plus 3 and get this one, solve it and get the result. This is the result of y, derivative of y with respect to x, and I solve it using the chain rule throughout t. Okay, so the idea is the same, but the terms and the symbols sometimes a little bit different in the way we get to the chain rule, the result of the chain rule, but both terms, both way to look at it should be known, and we can see it in many applications like backpropagation in machine learning, deep learning, and other things. Thank you very much. This was some words on the chain rule, and that's it. If there are any correction, please correct me.